Let's work through a problem. If I've got a mass 1 here and a mass 2 here, and let's put them a distance of 10 meters apart, and we'll make this mass m and this mass 2m. A question is, where can I put another mass so that it will be in equilibrium? Now, I'm not putting the mass in a position where all three are in equilibrium. I'm just putting a third mass in here so that it is in equilibrium, at least for that brief moment. So if I imagine a number line here, I'm going to put this third mass somewhere. Now, if I put the mass here, so if this is m3, recognize it cannot be in equilibrium there because it is attracted by a gravitational force to mass 1. It's attracted by a gravitational force to mass 2. If I put it over here, it's going to be attracted to both of them in that direction. And if I have two forces in the same direction, unless they're both equal to 0, there's no possible way that you can have a total force of 0. In other words, no possible way to have equilibrium. So the mass has to be somewhere in the middle. Now, since we have an unknown here, let's put an x, and so this is mass 3. And I really don't care what mass 3 is. And so this distance here is 10 minus x. And so the gravitational pull, it's being pulled towards mass 1 and being pulled towards mass 2. We're going to look at this from two different points of view. So let's just do it the simpler way to start out with, and then I'll go to the pickier way. So this is the force on 3 from 1, and this is the force on 3 from 2. I know that the magnitude of forces is going to be g mass 3 mass 1 over the distance between them squared, and that's equal to g mass 3 mass 2 over the distance between them squared. The g's cancel out, mass 3 cancels out, which is why I said I really don't care what mass 3 is, and so I'm left with mass 1 over that distance squared is equal to mass 2 over that distance squared. In other words, m over x squared is equal to 2m over 10 minus x squared. The n cancels out, and I'm left with a 1 over here. And I could go through the quadratic if I need to. So if I went through the quadratic, so I have 10 minus x squared is equal to 2x squared. This becomes 100 minus 20x plus x squared equals 2x squared, or bringing everything over. So I get 0 equals x squared plus 20x minus 100. And so x is equal to negative 20 plus or minus the square root of 400 minus 4ac. So that would be plus 400 over 2. So one of my solutions is 4.142 meters. And the other solution, negative 24.142 meters. So recognize that one of these solutions makes sense. We've already identified it's got to be in the middle, so that is the correct solution. So what is this actually telling us? Remember that we sort of ignored directions. We just looked at magnitudes here. This is the location here, and when the force from mass 1 and mass 2 are the same. So they are indeed same direction and magnitude, and it's being pulled in that direction. When it's closer to here, mass 1 will have a greater pull, and then the pull from both will get smaller, but the force coming from mass 1 reduces at a faster rate. And so when you get to 24.142 meters, the pull from both of them is the same, and then past that, the pull from 2 is greater than the pull from 1. But this is the point where they are equal but in opposite directions. That is not a Newton's third law application, by the way. So a different way of doing it, if we actually identified that the correct region, we know it's going to be in the middle, then we could have also solved it differently. So I had 1 over x squared is equal to 2 over 10 minus x squared. If I take the square root of both sides, I get 1 over x is equal to the square root of 2 over 10 minus x. So 10 minus x is equal to the square root of 2 times x. 10 is equal to square root of 2x plus x, which is square root of 2 plus 1 times x. So x should be 10 over the square root of 2 plus 1. The 1 is not under the radical. And you could go through and rationalize the denominator, but, you know, frankly, I got a calculator here. It's 10 over 2.414, yada, 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 divided by, and what? I get 4.142 meters. Lo and behold, it's the exact same answer that we had before. So just an alternate way, just another gravitation problem.